farabalẹ̀. Wà tó farabalẹ̀. Ẹyẹ ká oṣù náà ṣe. Yẹ lọ sùn lẹ́sùn. Please don't disturb me now.
Yeah, welcome to today's class. So, we want to be looking at the subtopic called the parabola. Okay, so you recall that we have started discussing the concept of parabola under the coding section, and then we'll see parabola for this basic class. Okay, we mean four things. Okay, so we have a case of a parabola facing towards this direction. Okay, and then this direction is what we use to formulate one formula, and after which we will use this concept to formulate other formula. Okay, so let's see what we have here. So if you have a parabola in this direction, okay, where this place is the origin O, okay, so that is the way we derive an equation for a parabola at the origin, and this is given as the equation y squared equal to 4ax. Okay, so the constant a here, this is the constant. Y, x and y vary from the x and y axis. Okay, so the point here is the constant here. Okay, as you can see, this is what we use to formulate this curve. Okay, so this constant a, okay, the constant a is called the focus of the parabola. Okay, so this equation, okay, that we have generated here, so is the equation representing this curve. Okay, so another form is that, okay, so you will see the origin that we have said here, okay, is usually, okay, sorry, let's move the vertex to the origin. Okay, so this vertex is from the origin, okay, and then we say vertex, okay, we'll say focus first. Okay, you see that the coordinate of this point here is a comma 0. It means the point at y is 0 and the point from here to here is a. So the focus in this case is referred to as, okay, we make use of this to f to represent the focus of the parabola, and so this is coordinate a comma 0. Okay, so this is the focus, and that thing here is the vertex. Okay, so the vertex, we use V to represent that. As you can see, the vertex, since it is at the origin, the vertex V has coordinate 0, 0. Okay, because this point is the vertex of the parabola. Okay, and you will see there is a line, okay, which is symmetry to this point. Okay, you see from here to here is a, y from here to here is negative V. Okay, so meaning this is symmetry to this. Okay, so this line, okay, which passes through the point of the symmetry point, okay, is referred to as directories. It's referred to as directories. So, and the directories is usually the equation x equal to, the directories is usually, as you can see, the pointer is negative a, so it's on a point x equal to minus a. So 3 things to note here. Anytime we have a parabola, we think of the focus of the parabola, and we have said the focus is the coordinate a, 0, given as this. Okay. Secondly, we consider the origin called the vertex, whose since this parabola is from the origin, okay, so the coordinate of the vertex is 0, 0. And last thing is this line called the directrix, okay, which is represented by x equal to negative a. Okay, so as we have said earlier, we can formulate another 3 forms of parabola from this graph. Okay, in the case where we have this parabola facing towards this direction, okay, so accordingly, what we just do is to reverse all the cases here. Okay, so if you reverse this and this, instead of this curve facing towards the side, so it's now facing towards this side. So what it means is that this negative a will now be the focus of the new parabola that we are talking about, while this line will be moved towards this side as the directrix. Okay, so let's quickly see this. So again, you see this is another form of the parabola, okay, the one that is facing towards the side. So accordingly, the origin remains the same, okay, while the focus will now change to, instead of this that we have, the focus will now be f of negative a, 0, okay. For this parabola, the vertex will be 0, 0, since it is at the origin. And thirdly, we have the directrix. Here it is given before as x equal to negative a, but in this case, the directrix will be x equal to a, as you can see. This is the line of the directrix. Okay. So similarly, we can have a parabola facing towards this direction, okay, just like a cup, okay, or a valley, okay, and there is another parabola, okay, which is like a dome, okay, or just like a cap in our traditional cap, okay. So let's see those forms so that we can formulate. So here, the equation of the parabola here would be negative 4a x, okay. So this is the equation of a parabola whose focus is this, whose vertex is this, and whose directrix is this. Okay. So let's see the curve that faces towards up, and then the one that faces towards that, so that we can represent those on two with an equation. Okay. So again, so suppose again we have a parabola of this form, okay, and let a point here call a point B, okay, be the focus, and then negative b. So again, this place remains the origin O, okay, and then for this parabola, we can formulate 4 things here too, okay. So I think this is taken. Let's use the next equation to formulate the next parabola. So here, okay, you will see the first one is facing towards the direction of x, okay, that's why the of y, okay, is depending on x here. But in this case, this one is facing towards the direction of y, so x in this s will be dependent on y in this case. So the parabola representing this type of equation will be x squared, okay, 4by. Okay, this is so because x is not depending on y, okay, and the point b here will now be the focus of this parabola. Okay, so the focus in this case is the coordinate. The focus f is the coordinate. Okay, you see that in this case s is 0, while y is b. Okay, so this is x is 0. So this will be the focus of this parabola, and also the vertex remain at the origin. Okay, so the vertex v is 0, 0, and then the directrix there, the directrix in this case, the directrix will be y equal to minus b. Okay, so this is how we formulate for this. So also, or finally, the last parabola, let's quickly look at that. Okay, I will just induce that from here, okay, without the drawing. Okay, so we'll see that the focus of this parabola, okay, is negative b in that case. Okay, so and this will be negative 4by. Okay, so in this case, the focus, this will be 0, comma b. This will be the focus in this case. The vertices, everything is at the origin. The vertex means 0, 0, and y, the directrix is y equal to b. Okay, because in that case, the line here will be the line of the directrix. Okay, so these are the 4 types of so now let's see how we can solve a problem using the 4 concepts that we have discussed. Okay, so we are asked to find the focus of these four parabolas. Okay, so in each case, what we'll do is just to compare these equations with the aforementioned four equations that we have derived. Okay, we should also note that all these four equations that is given here are as vertex which is at the origin. Okay, so all these four equations, they are vertices at the origin. Okay, so there is no need of finding the vertex of each of them. Okay, since we know it will be 0, 0, and what we can just do is we can find the equation of the directrix for each of these parabola. Okay, so but let's see how we can get the focus of each of these. Okay, so solution, that is for one. So we are given y squared equal to 20x. Okay, so when we compare this with this, okay, by comparison, okay, when we compare this with this, okay, here we see that 4a is equal to 20. Okay, and this implies a equal 5. Okay, so by dividing both sides by the coefficient of a. Okay, so what our conclusion will be that therefore the focus whose coordinate for this type of equation is a comma 0, okay, will be equal to 5 comma 0. Okay, so straight away the focus of this parabola, okay, is this f 5 comma 0. Use the equation of the directrix. Okay, we can use the equation of directrix, okay, as x equal to -5. Okay, so let's see that up here. So its directrix, or its line of directrix, is x equal to -5. So that's all. Or you can see x plus 5 equals 0. Okay, so whichever way. Okay, so let's see this. Okay, so you will see that since we're having negative here, okay, this is the case of a parabola facing towards the side. Okay, and here y is depending on the curve, y is depending on x. So this is the case of a parabola facing towards this side. Okay, that is a parabola of this form. Okay, so how do we compare this? So if you are given y squared equal to -16x, okay, so here we have, so by comparing this, okay, so we should know what is happening there. Okay, so we see that the point A here is 4. So by comparison, okay, and this one we have a focus of this form. Okay, of course the focus is a negative a comma 0, and this will be f of -4 comma 0. This will be the focus, and the directrix of this will be x equal to 4. Okay, but this will be on the opposite side of the parabola. Okay, or the symmetric part of the parabola. Okay, so let's quickly see number 3. Number 3 is given by this. Okay, and this is number 4. So let's see this. So let me transfer this one down. So again, we can compare this equation with this negative 4by. Okay, so and this means that if you are to compare, this means 4b is equal to 36. Okay, and b in this case is a 9. Okay, so b in this case is 9. So by comparison, we see that b is 9. Okay, so because of this negative, we see that this is a parabola that looks like a dome. Okay, parabola facing towards this direction. Okay, so here we can have the focus of this as the focus is the coordinate as 0, negative b, and this will be f of 0, negative 9. Okay, and finally, we'll see that this focus also is like that of this, but this is the case facing toward the this one is facing upward. Okay, so when we compare this with this also, you see that this 4 here is the point B here is 10 by comparison. Okay, so accordingly, so the focus is which is this will equal to 0, 10. Okay, and of course the directrix equation of the directrix will be y equal to minus 10. Okay, or y plus 10 equals 0. Okay, so this is how we find the focus and of course the directrix of each of the parabola that is given. So you will see that all the parabola we have considered there are parabola from the origin. That is a parabola that is constructed from the origin. Okay, so there are many cases where we can have a parabola whose vertex is not at the origin. Okay, but before that, let's quickly look at the tangent and normal of a parabola whose vertex is at the origin. Let's quickly look at that. Tangent and normal of parabola whose vertex is at the origin. Okay, so we only pick one case here. Okay, and that case can be used to generalize by you. Okay, so let's see that quickly. So suppose we have so this is a case of a parabola whose vertex is at the origin. Okay, let's see. So for a parabola, I want to see a parabola of this form. Okay, the equation of tangent of this parabola of this form. Okay, so when we talk about tangent, okay, it is the kind of equation, okay, that we can get from any of these points of this parabola. Okay, the point of this parabola. Okay, suppose we want to find the tangent of this parabola touching this line, the line of parabola at this point. Okay, so it is a line. Okay, the line of the tangent is this. Okay, so and this line, okay, will form a kind of a line to the focus. Okay, especially that it will be the line from the focus to the point at which the target line is touching the curve of the parabola will be perpendicular to the, it will be a point perpendicular to the line. So let's quickly see that. So suppose we are given this, okay. So this is the equation of a parabola representing this. Okay, we're only taking one form. Okay, so if you want to know if you want to find the slope of this, okay, so we differentiate this implicitly. Okay, we are doing so because of the so if you differentiate this implicitly, okay, we have 2y, okay, because y is depending on x. Okay, so anytime we differentiate y, okay, this will accompany the slope dy dx. Okay, so and this is when we differentiate this side, this will be 4a. Okay, 4a is constant, yx is a variable there. So if you differentiate x in that case, it will be 1. Okay, so from here, you see that if you make the y dx a formula, this will be this equal to 4a all over 2y. Okay, so we can take 2 out of this, so that this will be 2a over y. Okay, so we say let this be m, which is the tangent, or the slope of the parabola, whose of the parabola this, okay, whose vertex is at the origin. Okay, we must emphasize that. Okay, because that thing alone is key to this thing we are doing here. Okay, so now suppose the tangent line now touches the circle, okay, or touches the parabola, okay, at a point x1 comma y1. Okay, so this is how we now go about it. Okay, so suppose this is touching this here. Okay, I want to form the equation of the tangent line, equation representing this line. Okay, so we now say the equation of a tangent, okay, which touches the parabola, which touches the parabola y squared equals to 4ax at the point x1 comma y1, okay, is y minus y1 equal to m x minus x1. Okay, and of course we know that this m is given as 2a over y. Okay, so we can replace this as thus. Okay, so if we replace this m here, this will be 2a all over y1. Okay, because the point here has been stated as a y1. Okay, and this is a x minus x1. Okay, so this equation is the equation of the tangent which touches the parabola of this form at the point x1 comma y1. Okay, so with this point y here is now known, because it is y1. Okay, so just replace entire thing here by replacing this with y1. Okay, here. Okay, so after that, okay, I think we are okay with the equation of the tangent. Now for the parabola. Now for the normal of the parabola. Okay, so we know that the line of the parabola, okay, must be a line which is perpendicular to this line. Okay, so and because of that, it means the slope of that line, okay, must be perpendicular to this slope, because this is the slope of the tangent. So the slope of the normal must be perpendicular to this also. And in this case, this will be given as this. Okay, so for the normal, so if you have any question, please let me know in the comment section. Okay, let me know if you have any question. Okay, so I'll attend to that after going to your question. Okay, so for the normal, so let's m2 be the slope of the normal of the parabola so then if m2 is the slope of the normal to the parabola, okay, then we see that m1, in this case we call this m1, that is the slope of the tangent. Okay, so m1, m2 will be this. And in this case, we can get m2 to be negative 1 over m1. Okay, so since m1 is given by 2a over y, okay, accordingly, the slope here will be negative y over 2a. Okay, so m2 in this case will be this. So with this, we can now get the equation of the normal to the parabola. So let's quickly look at this. So now say therefore the equation of the normal touching the parabola at x1, y1 will be given as y minus y1 equal to m2 x minus x1. Okay, so by replacing this slope of the normal, okay, into this equation, this will be this. Okay, so this equation is the equation of the normal to the parabola y squared equal to 4ax. Okay, so you should note this. I want to give an assignment. Okay, assignment now. Okay, I will send a link where you send your assignment. Okay, or exercise. Let's call it exercise. So I'll send a link where you can put the for that. Okay, so the question is, or the assignment is this: find the, okay, let's see, exercise, find the equation of the tangent and normal to the following parabolas. So the first one, so you will recall that the equation of tangent and normal that we have deduced is from a parabola y squared equal to 4ax. So in this case, we want you to find equation of normal or equation of tangent and normal to this. Okay, if the parabola is this, so if the parabola is this, so 2 is if the parabola is x squared 4by and then 3 x squared minus 4by. Okay, so find the equation of a tangent and normal to each of these parabola. Okay, so let's take this as an exercise. Okay, so I will send a link where you can submit your answers. Okay, so and don't forget, if you have any question, okay, so feel free to ask me in the comment section. Okay, so this is it. Okay, now let's now go to the part 2 of the parabola. Okay, this is a case where the origin of the parabola is not at the origin 0, 0. Okay, so in this case, suppose we have moved the origin from 0, 0 to another point. Okay, so if that is the case, we will now, okay, if this has been taken, let's rub this so that we can talk about that. So let's give this a subtopic, transfer of origin. Transfer of the, okay, transfer of the origin. Okay, stay on the parabola, okay, but transfer of the origin. Okay, so suppose you have this diagram. So you will recall that the parabola we have talked about before has this vertex here. Okay, that is the parabola of this form. Okay, this is the vertex, this is the origin O. Suppose this origin, suppose we want to move this origin away from here. Suppose we are taking the origin to the side. Okay, okay, so what we now do is that, it means we are shifting this origin to this side, meaning there will be a coordinate different from 0, 0. Okay, so let the coordinate be, let's say, the coordinate here, let it be S star, and let the coordinate, so that this will be S star, Y star. Okay, so in this case, okay, instead of the parabola here, okay, we now take the parabola to this place. Okay, so that's what we refer to as the transfer of the origin. Okay, so the vertex is now, the vertex has the origin X star, Y star. Okay, so that's the original origin. And of course, we can see that this line. Okay, so let's quickly see this. So we have transferred the origin to this point, and the vertex is like this. Okay, now suppose we now have the focus of this parabola, just like we do for the previous one. Of course, let the focus be, if the focus is A as it is there before, okay, we now see that the focus has been shifted. Okay, and in this case, the initial one is A, 0 for a curve like this. Okay, so because this point now has been affected by these 2 points, okay, so the focus in this case will be, okay, it should be no more this, it won't be this anymore, okay, but it will be, the focus will be A plus X star, Y star. Okay, so you recall before that this point here is 0. Okay, okay, so that the new Y star will be added, will be coming here, because the point here is normal the origin. Okay, so this will be this. So this will now be focus. Okay, so this is the focus. Similarly, this will also be affected by this at this side. Okay, it will be affected too. That is the line of the directrix. Okay, so the line of the directrix, it will be a line which is symmetric to this. Such a line will be somewhere here. Okay, as the case may be, depending on the choice of what A is and this point. Okay, so if this number is big enough, okay, it means this will be somewhere around there or around there. Okay, it depends. Okay, so in such a way that we measure the length from here to here. Okay, when you take the measurement backward, okay, we can have the line of the directrix. Okay, so this is how we do it. Okay, so simple, but one have to be very careful. Okay, so the same way we'll do for other cases of parabola. Okay, so if this has happened, okay, for such parabola, what we now have is the new equation for the parabola will be y. Okay, so we are using an equation for this now. Okay, or we are writing an equation for this. Okay, so you will recall when we have this case, when we have a case where the focus is like this, so the equation of the parabola is this. Okay, so what it means is that if you now have a case where, so what we now do is when the point has been transferred away from the origin, the case we will now be having is replacing each y, anywhere you see y, replace it with y minus y star. Okay, and this one will remain 4a, and of course, whenever we see x, we replace it with x minus x star. Okay, so this is how we do this. Okay, so we have replaced the point here. Okay, so this equation now is the equation of a parabola whose vertex is x star, y star. Okay, and the focus in this case will be of this form. Okay, and similarly for all other forms of a, we can use the same thing for all other forms. Okay, so having got this, we can now bring a question. Okay, of this form. Okay, so let's see how we can ask a question on this. Okay, so let's solve this. So now let's see. So we have said that the parabola we have formed for this, okay, can also be done for, we can also transfer the origin of these other cases. We have only done for this, okay, so your own case, okay, so you can use how we can of this. Okay, so here we want to find the vertex and focus of the parabola. Okay, of the parabola y equal to, okay, Okay, so let's look at this. So we want to find the vertex and focus of this parabola. Okay, so the first thing to do is to first write this in the standard form of a parabola, after which we will now deduce what we are asked to find. Okay, so to do this, okay, see that to do this, so this is what we do. So we will okay, so let this be 4. So for good sake, so we now see that we can write this as y square So if you write this as this, so here we can split this into 2. So that this will be 9. Okay, this will be 4, and this will also be 4. Okay, so we'll see that this is okay, we can have a perfect square from this. Okay, so that this will be y minus 3 square. Okay, and also here we can factorize 4 or negative 4 out, so that this will be x minus 1. Okay, and everything will be equal to 0. Okay, so this will be y minus 3 square equal to 4 x minus 1. Okay, so if you compare this equation that we have derived with y star equal to 4 into, okay, or 4a x minus a star. So by comparing this, okay, we'll see that the vertex, so by comparison, okay, we'll see that the vertex x star, y star will be equal to, look at this, you see that y star is 3 and x star is 1. Okay, so this vertex is 1, 3. Okay, and similarly the focus. Before we get the focus, we can see when we compare this. Okay, so at least if we compare this, we see that 4 equal I equal 4, and this implies a is 1. Okay, so if a is 1, so in this case, so the focus will be this, comma y star. Okay, and this will be equal to, we have known the a here to be 1. We have also known this to be 1. Okay, so this will be f of 1 plus 1, comma 3. So this will be f2, comma 3. Okay, so the focus of a given parabola, okay, is 2, comma 3. While the vertex, okay, that is the origin of the parabola, is 1, comma 3. Okay, so this is how we solve problems on the case of a parabola whose origin is transferred. Okay, so like I said, we can do similarly for other forms. Okay, so let's give one of the form. Maybe for the case of a parabola is looking upward. Okay, so let's see a case there. Okay, so let's call this example 2. So find the vertex and focus of the parabola y equal to okay. So this is another case of a parabola. Okay. So we're looking at this until you write this in its standard form before we can know where it belongs. Okay, so let's see this quickly. Okay, so the first is to write this in the standard form, after which we will now uh, classify, after which we now find the vertex as well as the focus of the parabola. So solution. So we can write this form as follow. We have y equal to x squared minus 4x plus 9. We can write this as 4x plus 4 plus 5, so that this will be x minus 2 squared, okay, plus 5. I will say that x minus 2 squared equal to y minus 5, okay. So if you compare this, with x minus s star square equal to 4b y minus y star, okay. So we'll say in this case, if you group this as this, you see that 4b here in this case is equal to 1 by comparison. Okay, that is, the entire number here is 1. So when we compare, it means 4b here is 1. Okay, and this implies that b is equal to 1 over 4 for this case. Okay, and in this case, so if you compare this to this, you see that the vertex x star y star will be 2, 5. Okay, and of course you will see that this is the case of a parabola facing towards the direction of the. So in this case, this will be facing towards facing upward. Okay, this is the case of a parabola doing that. Okay, so we'll see that this is the case where we have a parabola of this form, b plus y star. Okay, this is how this will look like. This is how the focus of this will look like. Okay, when these 2 points are the point of the vertex. Okay, so if you compare this with the first one we generate, okay, from the origin, you see that the case where this is 0 and this is 0 will be we have focus f of 0 comma b. Okay, so because of these 2 points that are now added, okay, so this will be f of 2 comma 1 over 4 plus 5. Okay, so when we add this together, okay, so the focus will be 2 comma whatever we have there. Okay, so this is how we do this. Okay, and the other 2 forms, okay, I think I will have to give you that as exercise, so you can have something to practice. Okay, so this is how we find the vertex and the number of So this is how we find the vertex, the focus, as well as the equation of the tangent and normal to a parabola. Whether the point is at the origin or is transferred away from the origin. Okay, so you can deduce also the knowledge of equation of tangent and normal when the origin is transferred. Okay, so we can do all that. Okay. So based on the other forms that we have here or that we have talked about, okay. So other forms of the examples will be given, okay, so that as exercise, so that okay we can see how or know how to solve them. Okay, I think it is honorable to stop here. Okay, so when next we have our class, we'll be talking about ellipse, the equation of ellipse, the one at the origin and the one which not at the origin, as well as the equation of tangent and normal. So also have a hyperbola to talk about. Okay. So rather than this, if you have any questions, so let me know. Okay. Other than that, you can stop it. So thank you.